These lecture notes come from an AP Statistics website. It's really a helpful site, so I put the link at the top of the page here. And they've got a video of their own that goes through how to calculate correlation coefficients. It's a 17-minute video, so it goes into a lot more detail than what I'm going to talk about here, but it's a good resource for you, so feel free to click on those links at the top of the page. In our discussion of correlation coefficients, there's a bunch of different types, but we're going to stick to just one, which is linear association. So we're going to try and establish a connection in our lab data between two variables that is linear or follows a straight line. So the way that it works is you're going to be given an equation, and that equation will be used to calculate a value. That value, called the correlation coefficient, ranges between -1 and 1. And the value that indicates the weakest relationship is the value of 0. So as you move away from 0 in either direction, you get a stronger relationship between your two variables. If it's moving in the positive direction, that means that you're getting more and more of a positive correlation, which means that when one variable gets bigger, the second variable gets bigger as well. If you move in the negative direction from 0 towards -1, that's considered a negative correlation, and as the value gets smaller or closer to -1, the interpretation of that is that as one variable gets bigger, the other variable gets smaller. So this is outlined in the notes, and when you get a correlation coefficient around 0, it just shows you that there's no direct linear relationship between the variables. And how this looks on a graph, if you look at these scatter plots, the top left here shows a positive correlation with an R value. R is the symbol for correlation coefficient. The R value here is 1.0, which is maximum. What that means is that this is a straight line. Every one of these dots falls on this straight line. It is a purely linear relationship moving in the positive direction, showing that as one variable increases, the other variable increases simultaneously. The middle graph here shows a positive correlation that's not perfectly linear, but it is close to perfect, and it's got an R value of 0.80. So it's close to that 1.0 value, indicating that there is a strong positive correlation in the data, but you'll notice these data points do not all fall directly on a straight line. And then the graph on the far right shows a 0 correlation. And if you look at the data points here, there is no linear relationship that you can draw between the data points. The three graphs below those show negative correlations. So the graph on the left is a perfectly linear negative correlation with an R value of -1, showing that as one variable increases, the other variable decreases. The middle graph in this series shows that we have a moderately negative correlation. There is a linear relationship here, but it's not a strong linear relationship. And the last graph is here to point out what an outlier can do. So you'll see the data point up here. There is a strong positive correlation. These points all follow the graph, all follow a perfect line. However, this outlier up here actually brings the R value down. So it's very likely that our experiments that we're going to conduct in this class will have outliers, just kind of random points that don't follow the trend. And so we can use a correlation coefficient to interpret those results. How you're going to calculate this is really well explained in this AP Statistics video. So if you click on the video link at the top, or if you go to the actual website with the URL I provided and then look at the video, there's a great deal of time spent explaining how to calculate a correlation coefficient. There's two things you'll need to be familiar with. The first one is called a deviation score, and I took a screenshot of the video here. The deviation score is simply the relationship between the raw score for an observation and the mean of all of the raw scores. And I can show you this in class, how to do this in more detail. And then you'll need to know what the correlation equation is. So the equation for a linear correlation coefficient is R is the sum of the deviation score for X times the deviation scores for Y, divided by the square root of the sum of the deviation scores for X squared times the sum of the deviation scores for Y squared. And this is an example here, again, it's a screenshot of the video provided by this AP statistics teacher that this screenshot shows you how to solve 4R. So I would encourage you to try these test problems at the bottom here. There's one test problem with a few questions about it to see if you can correctly get the solution that's provided for you. And if you have any questions, again, this is a good time for you to send me a message and say, let's get together and talk about this.